Hello, thanks for joining us. My name's Ed Silverton. I'm at the Fusebox in Brighton. This is the first Fusebox Ask Me Anything. It's a new thing we're trying out. It's part of the Brighton Digital Festival. And we're very lucky to have Jim Pick on the line. And he's going to help us understand the DATS protocol. Jim Pick's co-founder of Backblend Systems and co-host of the Datcast podcast. He's a renowned DAT expert and speaker at the Internet Archive's recent Decentralised Web Summit, where I met him. So I thought we could start off by just talking about how you got into DAT, Jim, and what drew you to it. What was your first experiment with DAT?
Okay, so hi, I'm Jim, software developer. I'm based in Canada on the west coast, Vancouver. And I've just been programming since the 1980s, so I've got 30 years of experience building various things. I've been through a whole bunch of different, been involved early in quite a few different software projects, such as early days of Linux and Debian Linux and Node.js. And I'm really excited about the latest peer-to-peer decentralized web technologies. And I've spent much of the last year really focused on the DAT project. I came across that. I've really sort of been watching the evolution of it probably for about 4 years because was heavily involved in the Node.js early days, and I followed Max Ogden, who is the creator. He started the that project, and it was originally sort of like almost like a Git for CSV files, and it wasn't really a problem I had. I wasn't really that interested in it at the time, but over a course of several years, it sort of morphed into what it is today, which is sort of like a file, a way to transfer files around, primarily developed for researchers. And I was working at a startup last year, and we were doing podcasting, and I was quite interested in the technology, and I also had 6 months I was taking the top 50 podcasts off of iTunes of all the top podcasts, and we were building machine learning tools that would convert the podcast content. We'd transcribe it all, and we'd had this interactive transcript player. And so I had this, I built up like a machine learning corpus of all these text transcriptions as well as the data. And the data was quite huge. And I needed to shuffle it between, we had free credits with like Amazon and Microsoft and Google. So I needed to transfer files between data centers. So it was sort of bleeding edge, but I got to play around with it, and I had the computing resources to play around with it. So that's how I first sort of started tinkering with it. And
for Ross, one of his demo, the Internet Archive was putting Wikipedia into a DAT, all of Wikipedia into a single DAT archive. But so you mentioned you were dealing with quite large files. I guess my first question is, how large can a single DAT get? I remember Frost had to break it into several zip files. But
yeah, so I just listened to Matthias Boos, also known as Macintosh, that's his internet handle. Listened to a podcast recently, and he was talking about that project specifically. And that project pushed the limits of what was the current version of DAT was capable of doing. Of course, he's been working on a newer version of it, which he's been working on for really several years, and it hasn't yet replaced the current version, but that one addresses the scalability limitations. So that's one of his tests, is just loading up Wikipedia.
Right, so Frost is an active participant in the DAT community. He contributes code, right? And
Yeah.
it's also, I mean, it's quite similar to Git, isn't it? The DAP protocol in some ways. You mentioned, I think, versioning as well. Yeah, it has that support. What makes it different to the Git protocol?
So Git is sort of notorious for uh, not dealing with very large binary files. Like if you put a lot of images, you don't really want to check them into Git. There are ways of using large files with Git, but they sort of be like sort of add-on to Git. Git was designed for managing the source code in the Linux kernel, which is like millions and millions of lines of text code. It's very good at like little diffs of, you know, small changes and making a big pile of those, managing all that. Um, but that is really for data sets. They that was developed, was funded by a nonprofit, by foundations had funded their nonprofit to develop this for research scientists. And they worked closely, really from the start of it, developing tools that the research scientists could use. And they ended up, the problem the research scientists had were just, it's almost like Dropbox. It's like, how do you get large files from one researcher to another researcher? And so they focused on, you know, it's really good at big binary files.
Right. I ran into this with a Unity project in Git recently. Large binary files not working well. But I hear that they use YAML. They switched to YAML a while back to make that easier for working with Git. So that is, it started off life as a tool for sharing data sets for scientists, but now it's a lot more than that, isn't it? It's kind of grown to be a fully fledged kind of way of serving whole websites and even chat clients. And like, so Beaker Browser is the kind of canonical example, I guess, of, you know, building your own website in a and sharing it over a peer-to-peer network. How is that affecting the DAP protocol? Is it pushing the boundaries of what that is really for, or is that really flexible, and can it continue to grow into new use cases?
Yeah. That protocol, like the core of it is really been built by Matthias Boos in Copenhagen. And he, you know, it was built for research scientists, but for years before that, he'd really built a lot of the JavaScript libraries for dealing with BitTorrent. And it was really built at the core of it to be sort of BitTorrent version 2. So he's really been passionate about this problem for probably close to a decade. So, you know, like what we're seeing with the DAP protocol is just, you know, it's almost like his lifelong quest to try to solve these particular problems. And so, yeah, so
Sorry.
yeah, it's just really good at, it's just basically file transfer and how do you manage files, uh, getting them across the internet, and distribution, I guess.
Yeah. So I was reading over the documentation. I consider myself a kind of a run-of-the-mill regular front-end developer who does a bit of back-end stuff as well, but does some Node.js. I am not a cryptography guy at all. So when I read the documentation, it's all a bit confusing. So as I understand it, when you create a data archive, it generates a public and a private key. And when you want to share, so in the documentation it says like a magic folder. It's like, you know, you turn this folder into a shareable peer-to-peer folder, and you get a public key which you can share with anyone, and that's almost like a password for them to access your data archive. and then you have the private key, which is stored in the folder, and that gives you alone the rights to edit what's in that DAT. And I get a bit stuck when it comes to the hashing, the discovery key, like the hashing of that public key. So the public key is like its address, it's like its IP address almost. And anyone anywhere can request the IP address and get that content if they have it, right? So it's kind of it's a bit like security through obscurity, is it not? There's no other authentication sort of built in.
Yeah, I think that's one of the challenges with it. So if you keep the public key private, and you're transferring files with somebody in the middle has no idea what's being transferred. But if they can somehow get their hands on the public key, they can request those files and synchronize it to their own computer, and then they'll have all the files and they can read them. So it's very important to keep if you're trying to not share those files with the world, you want to keep those public keys. You don't want to give them to too many people. So it's really it was designed for sharing data, public data between scientists. So that's the decisions they made. So in order to, but they do have the ability that somebody in the middle can't spy on the conversation. So it's that the person. So that's the discovery key. That is the mechanism for that. So whenever you're communicating across the network, it's right in the name, the discovery key, the discovery process, where it talks to the discovery servers to find the other people to talk about. It doesn't send the actual public key, because the public key, somebody spying on the discovery server could get that public key and then see what the data does. They could request the data themselves.
If you sent me a public key, that then to get the data hashes it, and then that's the discovery key, right?
Yeah.
And then it uses that to find it on your distributed hash table.
So so if I make a DAT archive and I put some data I don't want the world to see in it, and then I email you the public key to that, you can go and fetch it. You fetch it by hashing that key and sending that hash to the discovery server, and the discovery server says, hey, my computer in Vancouver has that data. And then you can just go talk to my computer. So.
When you say discovery server, there is no central discovery server, right? It's a swarm of discovery swarm.
There's actually several mechanisms. So initially they tried to do it using the BitTorrent distributed hash table, which is sort of nice because there's like tens of thousands, hundreds of thousands of people running BitTorrent, and the BitTorrent clients all have this distributed hash table thing in there. But it's actually sort of slow, and it's got certain problems. So Matthias he made a modified version of DNS, and he runs 2 servers. And so that's the sort of, it's not really, it's centralized in that it goes to those first, and then it goes to the BitTorrent ones. But you'll usually end up using the 2 servers that he set up, because they're just a lot faster than the BitTorrent one. So it's just sort of a nice optimization in that things happen a lot faster on the network. And because they hash the keys, nobody can really tell what content's being passed for. But there, you have to trust that Matthias is going to see that there's this IP traffic back and forth. He's just introduced a new project called Hyperswarm, which is, he's taken what he originally tried to do with BitTorrent, but he's made it better. Like so I think what'll probably happen is he'll stop running those 2 servers, and he's going to, there's sort of a chicken and egg problem where a lot of people are going to have to run these distributed hash table processes on their computers, and then it can use those ones. But it'll run very fast. It also enables them to do something called UDP hole punching, which is related to firewalls, and it will allow people to talk peer to peer without having to go through a central server. Because firewalls are a real problem when you're doing peer to peer. Because normally you run something on your laptop, you're behind the firewall. You can't just open up a web server, and people can't just connect to that from the internet. So
Matthias maintains a lot of very nice kind of GitHub repositories, most of which seem to start with the word hyper. So there, from memory, there's hypercore, hyperdb, hyperdrive, and now there's hyperswarm. And it seems like they all do one. It's like kind of the Unix philosophy. They all do one thing well, but that kind of uses all of those libraries and probably more, I guess, to function. How much? I think when I started playing around with that, I started looking at something like hypercore, and I was thinking, do I need to know this? Or is this like is this really a kind of implementation detail? How important is it to know how these libraries work if you're a DAT user?
I think as a DAT user, it probably is not where you want to start. I think you probably want to start with either the DAT command line or the Beaker Browser, or both at the same time, because you can start a project on Beaker Browser, create an archive, and then clone it over on the DAT command line. Or you could start a project on the DAT command line, make some HTML files, and load it up in Beaker Browser. That's probably
the JSConf EU talk by Tara Vansel about how to publish sites on Beaker Browser. I think that really, I saw a tweet actually after that of like this guy was saying this is the first time I've been actually sold on the decentralized web, like why it's good and why it's useful, and I totally go along with that. I think the UX of Beaker Browser is really key to kind of getting started with that and kind of onboarding people. And I think it's compared to maybe some other similar projects, it feels a lot easier to hit the ground running with it. Also, one of the things that attracted me to DAT was the kind of immutability that's built into it. So I'd experimented with IPFS, and that's kind of very kind of immutable. Or is that the right word? Everything's content hashes all the way down, and because of what I was trying to do, and people asked me this at the Internet Archive, what's the difference between these two protocols, and my answer was I don't know. But it does seem to come up a lot. So IPFS is a kind of a Merkle DAG of content hashed stuff, and DAT, it's a bit like the IPNS. It kind of creates the keys it's generating are not connected to the content in any way. Is that right? They're just a kind of randomly generated, almost UUID, and then that's the identifier for your folder. And then but then there's a Merkle DAG within that folder, but that content isn't. It's not the same as something like IPFS, where you can request the content hash for something in that folder. Is that correct?
Yeah, so I've been thinking about this a lot recently because I just started a new contract with Protocol Labs in September. So I'm actually, I've been working on DAT projects for the past year, and now I'm over in IPFS world. So I've really been sort of thinking, what are the differences between these two systems? And yeah, it's true. They're both sort of internally, you start from like, essentially like everything is represented. Like you take a big binary file, like an image or something, you chop it into a bunch of small chunks. You call them blobs, and you store them in there. And then you link them all together by like doing these cryptographic hashes. So like even if 1 byte changes, the hash changes. You can link them together with these tree structures based on Merkle trees. And so internally, both systems are using the same data structures essentially, which is very, very, very interesting. Where they differ is like how they use cryptography to tie things together at the highest levels. Um, what IPFS does that that doesn't do is every single item you stick in there is now addressable. So with that, if you put um, a bunch of files in, you're going to get a DAT archive, and you're going to, if you want to get a file out of it, um, you will first start with the public the public key for that archive. So you'll go find the public key for that archive. And then once you got the public key, you can fetch bits of it. It's really good at doing like sparse replication. So, and then it can very efficiently get that sort of like tree, and then it can crawl through the tree and then just get the specific file you want. But and that file is hashed, but you can't go and say, I just want this hash without you have to tell it how to get to that file. Whereas what IPFS does is you can just say, give me the hash. It'll talk everywhere on the entire internet. And yeah, so what IPFS will give you is deduplication. So
you could have, if I created a DAT with hello world.txt in it, and you created a DAT with hello world.txt in it, they're both, that hello world.txt is not the same. In IPFS, it's the same thing. It literally is the same thing in that kind of universe, right?
Yeah. So if you, oh, sorry, that always happens. So yeah, so if you, I think like if you think like a use case might be you have have a lot of photo collections in you publish them out in different DAT archives, and say it's this, you have a picture of the Mona Lisa, and you have multiple websites that use that picture of the Mona Lisa. You're going to have to store that multiple times. Now, the thing is, you could actually solve that with DAT, because DAT has a pluggable storage layer. So you could move that deduplication into a storage adapter that would understand how to deduplicate things. So that storage adapter might be getting it from a database system, or like if you're in a big organization. Like I used to work for a startup that did storage systems for hospitals, medical data, radiology, imagery, like CAT scans, MRIs. So like you might have a DAT storage backend that would say, hey, get these the blobs from the system. So that system could be IPFS. So you could actually combine IPFS and DAT together if you wanted.
The two protocols could, merge potentially in future. Is that on the cards, or?
Possibly. I think like IPFS has this concept, they call it the thin waist. So like IPFS can address like Ethereum and Bitcoin. They can represent all that within IPFS, and you can use this thing called IPLD, I think interplanetary linked data. So somebody could build a mapping of DAT into IPLD, and then you could, the actual structure that DAT uses to store the data in the very lowest level primitive, which is the hypercores, is very, very simple to represent. So I'm sort of thinking and tinkering with some of that myself, just to see if it would be possible. But yeah, so I think, but I think really, if you're trying to decide between one or the other, you really have to look at sort of operational concerns. So the thing going for DAT right now is Beaker Browser, I would say. Like it's really really nice that you can, you know, you the Beaker browser is in a lot of ways they're prototyping the future of the web, and it's really neat how you can just drop a bunch of files in, put it load it up in Beaker browser, then anybody can like clone that and make their own fork it, make their own copy of it. That's very, very, very interesting. The other thing that's really the upcoming feature, which is they're calling multi-writer, which will allow you to create an archive, but then you can go to another machine and you can authorize that machine to also write to that same archive. Or you can give the archive to somebody else and then authorize them so they can write to it. So you can have multiple people adding files into an archive. And I think that's a real game changer.
Aral Balkan did a great post about that, about how that could be the next web.
And so I know that stuff intimately because I still am a freelancer, and I've worked with Code for Science on that feature directly.
Sorry.
Yeah. So it's sort of in very, very early. You can sort of try it out right now. The problem is Code for Science itself, they're funded by foundation grants and donations, and they don't really have any money right now to continue a lot of that work. So they're going to have to put out a call for either apply for some more grants or get some more funding. So as opposed to an organization like IPFS, which is very well funded right now, Matthias is he's really been unpaid for the last year, but he's now joined up with Paul and Tara at Beaker Browser, and so the three of them are now setting themselves up as a startup. And
it's really interesting, the business model side of it, I suppose. I know that because I have a Hashbase.io account, and I kind of pin my DATs on there because when I close my laptop, I want them still to be available, and that's a kind of a valuable service. I guess is that linked to Beaker Browser Hashbase? I've never really understood the kind of connection there. It's Blue Link Labs, right? That create that?
Blue Link Labs is their company. So I mean, they sort of launched them separately. I think they were a bit reluctant to build it right into the browser itself because Beaker is sort of a prototype browser, and they sort of want to put it out there as the future of the web. And they're really, all the browser vendors are really paying attention to them right now. So they've really made a splash. But I think like if they built the hosting service directly into the browser, they don't want to be perceived as being this, like they want it to be really, really open. So it's going to be pretty important from a usability perspective that people they call it pinning, like can you keep the content alive? So like if you make a website in Beaker Browser on your laptop and you close the lid on your laptop, if there's no other copies of that on the internet, nobody will be able to load your website. So you really need a service.
Sorry. Well, Beaker can do that, right? So if I look at gympic.com and in Beaker, I can choose to pin it on my machine via Beaker. So does it do that automatically, or so if I'm and is it automatically available from my machine as well, or do I have to?
I'm not exactly sure, but I think it's like when you load my site, the default is that it shares it for like 5 or 10 minutes. And then, so the idea, it's sort of like BitTorrent, like a lot of people are downloading Game of Thrones, the night it comes out. It sort of distributes the load.
It scales with the demand, and then,
But they have a little UI thing where you can click on it and you can you can host the files for a longer period of time or forever. So that's really nice.
So
I was at the Internet Archive dweb Summit, and they had a workshop where there was someone there from Google, someone there from Mozilla, Paul was there from Beaker Browser, and we had to form groups and talk about kind of what we wanted to see from the future web. And one of the things that my group came up with was we really want to see browser vendors kind of cooperating more, and maybe standards emerging. It does sound like, from what you're saying with DAT and IPFS, kind of the kind of the gap shortening between those two. It does make me wonder whether a standardization working group might make sense, or I know that Mozilla. I've been trying to remember what it's called. Is it dweb lib or libdweb? That's the one. So that they have a kind of effort to kind of make, as I understand it, Mozilla Firefox more kind of pluggable, so you can write extensions more easily for the kind of dweb protocols. Yeah. So it seems like it's going in the right direction. It seems like it's going to, because that's one of the other problems really with if you're into this kind of dweb stuff. My big problem I've been facing with what I'm doing is I love the publishing mechanism of DAT and the fact that I can create a kind of mutable address that can be pinned in multiple locations. That's really killer feature for me, and it works very well with this IIIF stuff that I'm interested in. This mutability is built into that. I found it very difficult to do IPFS stuff with that. But the problem is that unless you've got Beaker Browser, you can't see it, and not everyone has Beaker Browser. So I needed a gateway, an HTTP gateway. So, and then the problem is, as usual, it tends to boil down to economics. Like, who's going to fund a DAT gateway? So I set up my own, and but I don't want everyone becoming reliant on that because I can't fund it myself. So recently, Cloudflare announced they were doing they've created a IPFS gateway of their own, and I wonder, they say in their blog post that they may look at other protocols. I wonder how likely it will be if we get a DAT gateway as well. That would be very exciting.
Yeah, the real problem is just really the web browsers themselves are built around the HTTP protocol, and there's a lot of security involved. The DAT protocol, it really wants to, in order to do things like hole punching and that, like browsers can talk peer-to-peer using WebRTC, but WebRTC isn't really truly peer-to-peer because you still need to have a signaling server, and it does some sort of hole punching itself. But it's also because WebRTC needs that signaling server. If you're using in an offline scenario, so if you're in a ski cabin or something and you have two laptops, they're not going to be able to talk to each other because they can't talk to the internet to talk to the signaling server. So it'd be nice if they could, the web browsers could talk directly to the network itself and use like Bonjour type protocol, multicast DNS they actually call it, so that if in an offline scenario, you could just computers could just talk to each other directly. You can't currently do that with web browsers, so that's where things like what Mozilla is doing with it would work with Beaker Browser, because Beaker Browser talks DAT natively, but like Firefox would not be able to do that. And Firefox, you can install extensions, but the extensions, the security model still doesn't allow them to talk directly to the network, because that's a little bit dangerous. So what they need to do is enhance the web browsers so that they can do that in a safe way. So, I think that's largely the thing that's sort of holding it back. So until that problem is solved, you really have to rely on gateways. So I've built some things with that, and for doing collaborative shopping lists, and it works great in just a standard web browser, um, but it does need that gateway, so I need to run a gateway. And in that particular case, the gateway is really lightweight and it's specific to that one particular application. But for say applications that talk to a lot of different data archives or dealing with like large images and things, um, that gateway would have to be beefed up a lot. So I think that would be an area where IPFS is like far in the lead.
Yeah, I think it's having a gateway is a critical piece of infrastructure for adoption for the sort of mainstream. I was just having a look at the chat. I've realised that my iPad here isn't showing me any of the chat, and it's going on.
There's Paul and.
Yeah. I don't think we have any questions as such, or sort of comments. So Ilya Radchenko, the feature in Beaker Browser isn't a pinning service since you stop sharing once your connection is closed. Yeah.
Yeah.
So more of a fine-grained control for how long you want to share a site when you're online. So
I think it'd be good. Yeah, it'd be good to get Paul actually to talk about this on maybe a future one, because I've had a few discussions with him about how say Hashbase could work, like Beaker Browser itself, because like they've built a service called Fritter, which is sort of like a clone of Twitter that runs without servers. It runs inside Beaker Browser and uses Beaker Browser specific things. But it's difficult for people to use because they have, like, if a user creates an account, they then have to go over to this other website, Hashbase, and create, pin their profile over there. And it needs to be integrated into the browser somehow for this to get mass adoption.
there's also.
I will say IPFS has the same problem. So I'm working with IPFS people now, and they have the same problem. They're when you build an IPFS app, the content has to live in the network somehow.
This is always something I think there's a few GitHub threads where I'm saying, please make it easy for people to run this on, Amazon S3. Like to connect it up with a S3 bucket. But then you feel like you're kind of blaspheming against the kind of everything. How decentralized, do you think we'll ever truly achieve nirvana in terms of like everything is 100%?
I don't think data centers go away at all. I think I think like I have under my, on my house, I can get some really cheap, multi-terabyte hard drives. And I can see, I'm going to put my personal data on those because it's just going to be cheaper. But I think for like commercial data and that's always going to live in data centers. So I don't think Amazon really has to worry about it. I think what I'm excited about is it's really going to change the way websites and applications are architected. So I think in the future, there's a real strong possibility that your personal data never leaves your control, and you just bring all the websites and the JavaScript to your data, and you basically rely more on open source type things. And it's no longer the world where you give all your data to Google and Google provides all the services for you, or Facebook.
So I know a chap named Andy Jackson from the UK Web Archive at the British Library, and he was asking me about private key kind of management. So if you're like an institution and you want to publish data on that, and you're doing that a lot of that, you've got all these kind of private keys scattered around in various folders. What's the best method? Is there a kind of a way to manage those so they don't get lost and become unmanageable?
Yeah, I think that's just going to be I think it's a new frontier, and I think that's really going to be really what the whole software industry is going to be like, sort of trying to figure out that problem, because it's going to depend on your application and who you are and what you want to do, and everybody's going to want to do it a little bit differently. I think like things like two-factor auth, like I got like these little YubiKey type things, is going to be part of the solution. Like, you're going to want to, passwords should go away. Passwords will go away. Uh, and then there's going to be like, how do you keep your keys secret? Like, how do you encrypt certain things? There's a lot of secrets going around. It's hard for people to wrap their heads around this, but it's really fundamental to everything.
Well, it kind
But
of
like
feels a bit.
right now, that's the problem everybody has right now. Like, I just got so I checked my spam folder, and it says, this password, send some money to this Bitcoin address. We have one of your passwords, and it was actually one of my passwords. And I was like going, oh, it's like this throwaway password I never use anywhere. But it's like, this is the problem everybody's dealing with right now.
This is a big leak recently at Facebook of access keys, right? Access tokens, and there's a big data breach, which kind of brings us to the forefront of people's attention again. And now you've got Tim Berners-Lee saying, he's founding a company where you're going to be in charge of your data. You're going to have these pods, personal online data pods, and part of me thinks that's fantastic and we should all be in charge of our data and self-sovereign, but the other part of me feels like we're returning to the days where we put money under our mattresses instead of putting it in a bank. Do you think that's a kind of a unfair analogy? Because I can't be trusted with my own necessarily. I might lose a USB key.
Yeah.
Or
I don't know. I think there's some really good services out there. Like, I use like 1Password, and I haven't tried some of the other competing ones. And if you use those sort of tools in the browser plugins, and it's like really tightly integrated into the new version of iOS, it works really, really slick. People will get their handles on this, and like, there's going to be really nice solutions in the enterprise space. There will be vendors that large institutions will be able to go to, and those vendors will listen to them and have solutions specifically for them. But this is a radical shift going to managing lots and lots of these sort of Merkle tree type structures, where it's very, very crypto. And it's the thing with these crypto keys and even the DAT addresses is they're actively user hostile. Like, you don't want to show those in your user interface.
there was a leaflet and it had a DAT address on it that you could go to, and it's like, who is going to type that in? Like, it's just like,
I wonder if anyone did type it in.
I think there is a bit of a UX issue there. So we've got a question from Paul Frazee, which is he's asking about what your thoughts are on copyright on the DAT web. How do you think we should handle copyright, and perhaps more broadly, how do you think people should make money on the web?
Yeah, I mean, this stuff really, it sort of breaks a lot of business models, but then it doesn't really. Like when I use Netflix, I'm actually making a copy of the movie I'm watching, right? Like, it's like it's copied, but it's only runs inside the Netflix app, and there's DRM on it, so there's no way I can copy it off. And I mean, you can use these mechanisms and slap a DRM layer on it, and people can protect their content if they're Netflix. The problem is, like, should people at the lower, like, should just me as an individual, should I be able to implement my own DRM? I mean, there's a lot of people that are really anti-DRM, so but like, assuming there is no DRM, well, people can just copy things. There's like the issue, like, if there's a tension there, it's like I do my website, I have the entire history of my website is syncable, and somebody that I don't know can just keep an entire copy of the website. What if I accidentally post something, say I accidentally post my password or something in there, and I delete it, like I I can just be like, I can politely ask everybody I, who's ever synced it, be like, can you delete that? But then it's up to them whether they want to do that.
So
So
if I accidentally commit my .dat folder that's got my secret key in it, and
mhm,
because Git keeps everything around forever, sort of thing, I'm kind
yeah,
of I'm screwed.
uh,
But that I was reading earlier, it doesn't work like that. It's versioned, but it doesn't keep the full version history. Or maybe I'm completely wrong there.
well, fortunately, there's like when you create a .dat archive, there's a .dat directory, but your private key is actually stored on your home directory. So I don't think a lot of people realize that. So it's unlikely that you would commit your private key.
Right.
Yeah. So there is no mechanism for key revocation. Um, so there's that problem.
Yeah,
But
yeah.
you can just create a new one, I guess, and get people to use the new one. Um, but yeah,
Um,
you have to be a little bit careful. That I think Matthias and that's talked about, like there's a lot of people want to have a solution for like actually encrypting the files that are inside the DAT itself. And you do have your private key, so that could be reused in some ways. Um, that wasn't in the initial design of DAT because DAT was for facilitating sharing between these researchers. So, um, but
here, like to ask a question.
Yeah, I've got a very basic question,
Do you wanna speak?
and it's just to say, with Beaker Browser, if you're saying there's a way for everybody to see information for you to publish directly from the browser, how does that square with the idea of people must know a public key in advance? Do you share one public key for everything on Beaker Browser, or how could that work?
Could you hear that?
um, so there's not one public key for everything in Beaker Browser. There's one. So the actual, like your dat colon slash slash and then the string of hex digits, those hex digits are the actual public key. So as long as you have those, um, you can use that to both get the files, but also decrypt the files so you can see them.
Okay, thanks. That makes it clear.
We've got another question from Paul. When building apps, what do you think the full P2P web stack should look like? Is it files plus peer channel? Do you think HyperDB's key value store is important? What about CRDTs?
So yeah, so CRDTs are really quite essential, I think. So everything's built on immutability. You create a file or you create a record, and it can never be changed, but you can always add new ones onto the pile. And then you have these computer software like stitches it all together and gives you your, so you never really deleted the file, but you put a record that says, hey, that file, it's like a tombstone record. It's like that file was deleted. So the UI will show that it's gone. And the CRDTs, it stands for conflict-free replicated data types. And that's a way of um, turning all these immutable data structures so you can have multiple people writing to the same document. It's sort of like Google Docs, how to stitch it all together and provide like a unified view that sort of deals with conflicts and deletion.
Docs originally, the CRDTs, was it? I remember hearing that. That's where the kind of original research was pioneered. But maybe I think I was talking to Pedro Teixeira from Protocol Labs. He's an expert on this, and I don't know. I thought that's where that came from. Maybe I imagined it.
Yeah, that's the team I'm working on right now is Pedro's. So yeah, I think they're really essential. So if you want to have mutability, so because you want to be able to add files and delete files, and change your shopping list or type things into the chat and have things update. So CRDT types of technologies pair really well with this type of thing. So because people don't, the things people want to do with computers are not immutable. They want to do mutable things. So and yeah, so they're just a natural fit, actually. It all works together really well. So.
Do you think we'll get IPNS in? Because there's two versions of IPFS, right? There's the Go one, which has IPNS, I believe, but you have to kind of you have to download a daemon and like interface with that over HTTP, right? And I really like that because it's all kind of Node.js oriented, and everything's JavaScript, and it's there's no kind of talking to some daemon via an interface. It's all sort of the same stuff. So one of the things that led me to Dat was the fact that you could create IPNS style addresses and share them all in JavaScript. I wonder when that will, if ever, sort of land in JS IPFS land.
So the good news is that landed last week. So I haven't actually tried it myself, but but the problem with IPFS, so this is not even DAT, right? This is IPFS. But I don't know if I want to talk too much about, because everybody, it's hard to talk about two systems at once. But the IPNS, right, like right now, it's quite slow. So in order to get the sort of like instant, like if you change something in DAT, that happens, like the person on the other end can see it like right away. In IPNS is not that sort of immutability. So this is what I'm actually working on with the Protocol Labs, is they're using libp2p and CRDTs to provide that sort of instant response. So the next level beyond IPNS. So there's that particular direction. It could go 100 different ways. So it's hard for me to say right now what will be the equivalent to that. But like in some ways, like IPNS is sort of the answer to the IPFS answer to DAT. But because you can create, like when you make a website on IPFS, you add it to your node. That goes pretty quick. But then, like you could just share that hash out to everybody in the world, and they could fetch it. But then you can't change your website. Every time you change your website, you'd have to share another link, which obviously you just want to share the link once. So that's what you would use IPNS for. But like right now, when you do IPNS publish, it takes maybe like a minute for that to get updated. So that's not going to be quick enough for some people. So
I remember being told it's similar to a branch in Git. Yeah. It's pointing at a thing it's a consistent ID that's pointing at something that's changing.
Yeah.
Okay, so question 3 from Paul. Well, we have 5 minutes left. Maybe I'll move on to Ilya, who's got a question. How does that support app use cases that need to keep data private to a group of people, like a DM feature in Fritter? This is what I was kind of talking about with the Fusebox here, with our 5G experiment. Like if you're a business and you want to use that internally for sharing large files quickly and all of that, but you don't want it to leak outside of your organization. Does it support those kinds of use cases?
So I think there's two. I've thought about this because I actually have in my past, worked with all that medical data and that, and like how would I be able to sell this to hospitals if I ever wanted to do that? And they have HIPAA requirements, and it's really, really, really strict. I was thinking one simple thing that would be possible, and I've talked to Matthias about this, would be to take for over the network, make it so that you can guarantee that it never syncs to a server outside of your organization would be maybe do something fancy with the discovery keys, like mix in some secrets of your organizational secrets into there, and then it just wouldn't be able to connect to any outside thing. So that would be pretty easy to do. That would only be a couple of lines of code.
Like almost like a salted hash, maybe. Like
Yeah.
the discovery keys are hashes of the public key, and if you're adding a bit of salt to that only you know, then right.
And it could be like, it could even be like timed, like it changes every couple of seconds or something. And it could be like, it'd be limited inside your firewall. And so it'd be really tricky. I mean, somebody could copy all the like make a DAT archive in your organization, sync it to another computer. Somebody could just then copy those files and then, create another DAT archive that doesn't have that salt and do it. So it's not a panacea. And then there's the like encrypting the secrets inside. So like you can do it right now. You can take a DAT archive and use GPG on it and just like, or any other thing and just encrypt that. But maybe like using unified set of secrets might be useful for key management and things.
Another question from Paul. Do you imagine average consumers will ever purchase home cloud servers if the management ever becomes Apple level of convenient, or will it always be data centers?
I think totally yes, but I actually think that it's going to be like these sort of like Amazon, Alexa, Echo type devices, and Google and that, like your TV will come with something built into it, and all your IoT devices, and you can just slap in extra hard drives. I think that the cost of the solid state storage is getting so cheap now that they're just going to build this stuff into all your devices, and you're just not going to like. You can buy the new Apple phone, has 500, and you can get it with 512 gigabytes. That's as much as my SSD on my laptop. So you can just think your newest iPhone could just like peer with your home network, and that's probably all the backup that most people are going to need. So if somebody needs more data at home, they could buy hard drives, but they're probably not going to.
Joke about Pied Piper. I thought twice about it. So so yeah, I think I'm out of questions. We're at the. Do you have a question? Yeah.
Yeah, just about the discovery server. You mentioned that the kind of first stage is the kind of a modified DNS server that is hosted somewhere, or the BitTorrent DHT, which is slower. Is that something that will get faster as the network gets bigger, or is there some way of making that more decentralized?
Yeah, like right now, it's pretty much instant. The DNS server that Matthias hosts, of course, they're going to probably replace that with the Hyperswarm. Because it's just like really super small requests, like that part is really, really easy to scale. The only problem is it's a central point of failure. It even could be like if somebody posts some illegal content, the court system could try to force Matthias to take those things down. So the Hyperswarm approach, I think, is probably the better approach. And with the Hyperswarm, it should scale pretty well. So I think the more peers that are out there, it's providing all the code is good, it should scale very, very well.
I think a follow-up question there was whether is it Hyperswarm would be susceptible to attack.
No, kind of more DNS kind of discovery server.
Right.
It's a single point of failure.
Yeah.
It could also be man in the middle.
Yeah. I think all these things are susceptible to attack, but to take out an entire distributed hash table, I mean, it's really technology coming from the BitTorrent world, and that stuff's pretty unstoppable. So I think if you were to architect anything that was going to be unstoppable, that's what you would do. So, but there's always vulnerabilities and things. So.
Great. I think I think that's it. We've done a full hour. Really appreciate you joining us, Jim, taking the time out of your day to talk to us. It's been really good. Answered a lot of my questions, and I'm sure others. And thanks for joining us on chat as well on YouTube. That's been great. Okay. See you on Twitter.
Okay, it's been really enjoyable. Thanks for having me on.
It's been great. Thank you. All right. Bye.